Hey guys, how's it going? Today on Brad's workbench, I'm going to be showing off a lens I got for the Arducam HQ camera for the Raspberry Pi. And the lens I have is 8 to 50 millimeter, which means it has the zoom, and it's pretty cool to watch. So I'm going to be testing this out and having fun with it over the next period of time. And also, for fun, I'm unboxing it now. I have a adapter for the Raspberry Pi HQ camera. And let's install it and get this lens connected to something, and let's see what it looks like. Alright, so here's my current lens on my current camera. The camera you're actually seeing right here is a IMX477 also. This one has the 120 millimeter lens on it. Let me show you what that looks like. Here it is. Comes in this little box. You can see it's a lot smaller. So the lens you're actually viewing right now is this lens. Right here. So it's got a really protruding lens there. It's got a cover that protrudes too. So this is the USB cord for the adapter that allows you to use the HQ camera. Oh, didn't have to do that, but allows you to use this HQ camera. You want to know a trick to these ribbons is if you insert it and the plastic is covering, that means your contacts are down. But if you insert it and your contacts show, that means you insert it that way. But if the contacts show are going in and then you slide it in and they don't, I don't know, whatever opposite side the contact goes in from the clip. There you go. That works out a lot better. So we'll stick that in. And just like this one, the contacts are inward. It's crooked. Never do this whenever it's plugged into anything. And you'll notice how straight it is to the board. It should be exactly level with the board. Like this one has a slight line to it, and it's perfectly flush with the board. Now, time to sandwich this together. Get my screwdriver. Probably just do it like this. Just Z wiggled that thing in there. So the one thing I have noticed is that this camera works a lot better on a Linux platform because you can tune the settings through the UVC a lot better with the a native application. What I mean by native is like it's common within the distribution. It comes with it. And you don't see it on any other platform besides the Linux platform. I'm just plug this in just like that. Alright, time to add a tripod. And there we go. Sorry if that was loud. So I have a lens cap. It goes for the other side. So you need a CS ring for this. Needs to be a little bit longer. You can't use that standard mount. Mute. And so I just dusted that out real quick just to make sure that there's nothing on there. When in the box, it was kind of dusty. So there we go. It's really big. It's really huge on that thing. So I'm going to test on this thing. Let's move over to my Linux box. Alright, so where's my keyboard? So one thing to know is some of these cameras that you have, the HQ cameras, do have a different connector, or it's a different, for a different series of Raspberry Pi HQ camera. Like for example, the one that's made for the Jetson and the Pi module, not the regular Raspberry Pi, but the Raspberry Pi module, Compute 3, I think. Well, their thing is a smaller connector on those cameras, I guess, so they can tell what camera is for what whenever they get them mixed up. Something about the SPI lanes. But the camera this is viewing on is the Jetson camera. This is an actual Pi camera. I've had this one for a year or so. So keep that in mind, that this is the original camera that I'm testing on. The one you're viewing on is for this board, this UVC board, this little thing that I attached for the. We can work on both cameras because they give you another ribbon for that reason. All right, back to Linux. So the program that uses the change the settings for UVC is GUVC view. Yeah. So this is the command you want to install. Obviously, I'm going to have it already installed. You may not have it installed, but this is how you do it. Type in that command right there. To run it, you may need to do it as root, depending on your operating system, but I don't, because I have the correct rules set up for this, because I needed this to set up the camera, this one. So the one thing that's really tricky about this is that it'll start taking pictures. Is it? Yeah, it's taking pictures. So you got to start it a couple times, and it's not taking pictures now. But there is a good sign. I see stuff. That's the aperture. There we go. That is so. Let's do some measuring. so that way we can see the quality of this. So I got a cheap one of these because that's all I can get for my desk. So this is roughly $13 millimeters. So those squares that we're seeing on here are 13 millimeters. And I don't know what resolution we're running at right now. It's 10 frames a second. That still looks pretty good for, I guess, 720. Let's see how sharp we can get it. Oh, let's find out the distance from the lens to the object. Where are we looking at? Is it upside down? I think it's looking at the top. So is it looking at the top? Yeah, so that's looking at the top. We need to rotate this. All right. That's better. So distance. $175. That's the distance between the lens and this test board, and it's a 13 millimeter square. So that's how zoom in for up close. I don't have a direction right now to shoot it outside, or I would, but it's dark, so no zoom out. But we'll see how close we can get it in. What am I doing here? Let's go back out. I can always capture the whole board, see the angle. I got an idea. Let me take it off this extension that I have. There we go. That's definitely better. I'm gonna go square to square. distance. $163. All right, now let's try to zoom in. And zoom in all the way. Focus it out all the way. What square is that? Well, so far I think it's a good lens. Really sharp. Speck of something there. I just never. It's toner that fell off. Let me adjust the aperture. This is auto white balance, by the way. Auto exposure. I'm trying to get it as dark as I can. It's looking directly into the light. Oh yeah, see? Here's my lens. Alright, so this is one thing I didn't like whenever I first experienced it with my other one. You see that wave? Yeah, so you'll see my other streams where it was wavy like that. Alright, good. Let's fix that wave, because that was a problem I was having. So, I'm in here. Whenever you do it like this, there's pros and cons. The pro is you can adjust for your low light a lot easier, and white balance, and make it stick instead of having it auto adjust and like turn your images yellow, green, or blue. So first, where we gotta go is in here. We'll set the exposure to absolute. So once you set your exposure up, set it to the max. Alright, so that is set to a 5-second exposure. Alright, so that white balance. White balance needs to be adjusted. So I'll use this background that I have. It's actually pure white. So I'll use that for a white balance and to stop my anti-flicker because it shows up on that. There we go. Oh, no, there we go. That's even better. So every camera is a little bit different. So it's a lot of adjusting, tweaking, getting it to where it's right. So let's skip that part. But I got pretty close. But that would work great for a little robots, definitely. Really sharp. It's actually supposed to be more redder. So yeah, some more temperature color correction. But that is what it's all about. Trying to modify the settings of Windows is definitely a pain in the butt. That's all I gotta tell you. It's got a LED light to let you know it's activated, so you can tell whenever. Let's close the program. See what it does. There you go. Number light. It's the Arducam. Well, have a good one. I'll probably be making another video tonight or whatever, but see you next time.